The final major area of TQM that I want to talk about are the 7 tools of TQM. So the these can be broken down into 3 broad categories. First, we have tools for generating ideas, then we have tools for organizing the data, and then we also have some tools for identifying problems. In the first category, we have things like check sheets, scatter diagrams, and cause and effect diagrams. The second category contains Pareto charts and flowcharts. And the final category includes histograms and statistical process control charts. So let's talk about each. So a check sheet is an organized method of recording data. In this example, we see that we are counting 3 different defects, generically named A, B, and C, really original of me, over an 8-hour window. Check sheets are supposed to be a tool to help generate ideas about where problems may exist. Looking at this one, can you come up with any ideas? Well, different people will see different patterns. Humans are pretty good at that. What sticks out to me is that there are a lot of defects across all 3 areas at both the beginning and the end of the observation period. One guess might be that we're seeing handoff errors as employees are doing shift changeovers. Perhaps these are communication issues that are causing the problems during handoffs. A scatter plot, or XY plot, is a very common graphical tool that allows us to visualize how one variable interacts with another. This contrived example is almost hilarious. It is saying that as more and more people miss work, absenteeism, the productivity of the organization goes down. Pretty obvious. We often create one of these plots in an attempt to discern if there are any patterns in the data. This is especially true if the x-axis was time. That is, we'd be looking at a time series plot. Next, we have cause and effect diagram. This tool allows us to identify causes that might affect an outcome. It is also called a fishbone diagram or an Ishikawa diagram. The name fishbone is due to its visual layout. The head of the fish is the effect. That's the bad thing we're trying to avoid. And the bones are the different areas and specific attributes within that area. Here, I have shown a cause and effect diagram for wrong site surgery. Wrong site surgery is when you go into a hospital for a surgical procedure, say on your left leg, but they incorrectly operate on your right leg. Oops. Unfortunately, this happens more frequently than it should. There are 4 broad areas that have been identified as possible causes to wrong site surgery. We have staff, the procedural setup, preoperative assessment, and the OR environmental factors. And then under each of these areas are listed very specific causes that might lead to wrong site surgery. The first tool that helps organize the data is called a Pareto chart. It is a graph that identifies and plots problems or defects in descending order of frequency. In this example, we have 5 categories of errors, A through E. A is the most frequently occurring. We can see this because its column is the highest and also the first one listed. The points with the dashed line connecting them is the running cumulative amount of defects or percentage of defects. So the second dot is the total number of both A and B defects, often expressed as a percentage. By the time you get to the last bucket, E, this line should reach 100%. A flowchart is also commonly called a process diagram or a process flow diagram. It shows the steps of a process. When trying to make a process better, you often start by developing one of these to help determine where there may be room for improvement. The one here is very, very simple. There are many different symbols used in a flowchart. There are only 3 shown in this one. Ovals, they indicate the start and end. Rectangles represent a step of the process. And diamonds represent a decision. A histogram is good at showing the distribution of the frequency of occurrences of the variable in question. The distribution shown here appears to be approaching a normal distribution, the bell-shaped curve. Recall from your probability and statistics course that a distribution can take all different shapes, And in general, you need two parameters to describe a distribution. One, a measure of central tendency, so for example, mean, median, or mode. And the second one is a measure of dispersion, for example, standard deviation, variance, or simply the range. And then the final tool is a statistical process control chart. These are charts where data is gathered, usually at regular intervals. Some statistic is calculated from that data, and that statistic is then plotted. The center line, that is solid in this example, shows the goal or target value. Then we have dashed lines above that are called control chart limits, the upper and lower bounds of acceptability. As long as we're within that band, we seem to be okay. Supplement 6 from the textbook covers SP charts in detail, and that'll be our next topic later on in the course.